Welcome to This Explainer. Today, we're taking a pretty fascinating journey together. We are literally stepping into the digital world to unpack the evolution, the architecture, and the ethics of virtual reality. We'll be moving from VR's surprisingly mechanical origins all the way to its profound implications for our shared future.
So, here is the roadmap for our explainer today. We'll cover 5 main areas. 1. Defining virtual reality. 2. A century of virtual evolution. 3. Building the virtual world. 4. Far beyond video games. And 5. The ethics of immersion.
All right, let's get into it. Section 1. Defining virtual reality. The surface of the metaverse. Okay, so let's lock down exactly what VR actually is. Basically, virtual reality is a simulated experience employing 3D head-mounted displays and pose tracking to give you, the user, a totally immersive feel of a virtual world. It relies on a really seamless integration of stereoscopic displays, meaning it sends slightly different images to each of your eyes to create a true sense of depth, combined with super precise head tracking and interaction. This incredible fusion of hardware and software, that's exactly what tricks your brain and makes the artificial environment feel so incredibly real.
But what's truly staggering here is the sheer scale of this thing, $24.5 billion. That massive number right there represents the projected standalone VR commercial and enterprise market size by 2024. I mean, this proves VR is a fundamental technological shift. It's not just a passing fad, and it's definitely not just a niche gaming accessory anymore. It is a rapidly expanding, multi-billion-dollar industry that's completely reshaping how businesses and consumers interact with digital content.
Move in right along to Section 2. A century of virtual evolution, the surprising history of VR. Now, you might think VR is this brand new concept, but check this out. Look at 1956. Morton Heilig invented the Sensorama. It was this mechanical device offering a full, multi-sensory experience with sight, sound, and get this, even smell. Then jump to 1968, and Ivan Sutherland creates the very first head-mounted display. It was famously dubbed the Sword of Damocles because the hardware was so incredibly heavy, it literally had to be suspended from the ceiling. Fast forward to the 1980s, and Jaron Lanier popularizes the actual term virtual reality. And this timeline brings us right up to the modern era, highlighted by Facebook's massive $2 billion acquisition of Oculus in 2014, which, as we know, truly kickstarted the current consumer generation of VR.
And just notice the stark contrast between the past and the present here. On one side, early prototypes, like the 1980s NASA View, required users to be heavily tethered to these massive computer-bound machines. Your movement was entirely restricted. Contrast that with today's devices, sleek, untethered, standalone headsets that offer completely wireless mobile freedom. The evolution from a restrictive, room-sized endeavor to a lightweight wearable, that is a massive leap in engineering.
Which brings us to Section 3. Building the virtual world, the developer ecosystem.
So, the crucial point to understand here is that developers rely on a massive, highly sophisticated toolkit to build what we actually experience. To create real-time graphics and interactions, developers use heavy-hitting game engines like Unity and Unreal Engine. For the actual 3D modeling, creating the objects themselves, tools like Blender and Autodesk's Maya are absolute industry standards. And it doesn't stop there. Frameworks like A-Frame bring immersive experiences directly to your web browser using just HTML, while OpenVR provides the API to let these experiences run across entirely different hardware headsets. It takes a whole ecosystem of software just to build a single virtual world.
Let's pivot to Section 4. Far beyond video games, expanding real-world applications. Just look at how VR is transforming some of our most critical sectors. In healthcare, medical students can now practice complex surgeries in a completely risk-free virtual environment, and therapists are actively using VR right now to treat PTSD and phobias. In education, students aren't just reading about history anymore. They can take virtual tours and literally walk through ancient Rome, or dive into biology simulations right inside a cell. And in business, we're seeing remote collaboration in shared virtual spaces and architectural visualization where clients can physically explore buildings long before the foundation is even poured. And honestly, it goes even further into highly specialized applications. The military and emergency responders use VR for high-stakes training, so they can practice for natural disasters without facing any physical danger whatsoever. Space agencies use it to prep astronauts for leaving Earth. In agriculture, farmers use virtual simulations to map out and optimize really complex crop layouts. Retailers are even creating virtual try-ons for clothing so you can shop from your living room, and the tourism industry is offering virtual previews of global destinations. The boundaries of how we can apply this tech are practically limitless.
Finally, let's slow down for Section 5, the ethics of immersion, the core dilemmas.
Take a look at this really powerful quote from Brian Patrick Green at the Markwell Center for Applied Ethics. It perfectly highlights our core challenge. He says, "The reason technology ethics is growing in prominence is that new technologies give us more power to act. We have to learn how to be voluntarily constrained by our judgment." Think about that. Because VR gives us the immense power to simulate literally anything we can imagine, we must purposefully design these worlds with strong ethical constraints. We're no longer limited by physical reality, so our judgment absolutely has to step in. We also have to objectively recognize that these artificial environments inherently reflect the biases of their creators. And this creates some critical architectural challenges regarding inclusion and accessibility. Artificial worlds can accidentally or even intentionally exclude marginalized groups. This might happen through the inclusion of offensive stereotypes or simply a lack of accessibility for users with impaired vision, color blindness, or sensitivity to flashing lights. Designing a truly inclusive virtual world requires active, conscious effort right from the ground up.
Now, think about this personally for a second. Who actually owns the data of how you move your physical body? For these immersive environments to function at all, the system must precisely track your head, your hands, your unique physical movements. The way you move is a highly unique identifier. It's almost like a physical fingerprint. So who owns that highly identifying data? How is it protected? And how would you feel if it was harvested and shared without your explicit, informed consent? Well, currently, the user rarely owns this data.
To wrap up this explainer, I want to leave you with a final thought and a question to really ponder. As evidence emerges of virtual PTSD, where victims of virtual harassment actually describe real-world trauma symptoms, and the inevitable inclusion of manipulative digital Easter eggs designed to shock users, are we really prepared for the psychological impact of virtual trauma? Furthermore, in a limitless digital world where literally anything can be simulated, is true informed consent even possible anymore? How do we ensure users truly understand the real-world psychological weight of the artificial worlds they are about to enter? Thank you so much for joining me on this incredible dive into the digital world. I really hope this sparked your curiosity to learn more.